So what are inverses? Inverses basically undo something. They're the opposite operation in the opposite order. For example, if you were to put on a shirt and then a tie, inverse would be to remove the tie and then remove the shirt. Notice you go opposite order and opposite operation. If you were to get in the car and start the engine, the inverse would be to turn off the engine and then get out of the car. If you were to multiply y by 5 and then add 2, inverse would be to subtract 2 from y and then divide by 5. Again, opposite order and opposite operation. What does it mean to be a function? This is just a reminder. Basically, a function is that for any given input x, there's exactly one corresponding output y. Graphically means this passes the vertical line test. So in other words, if I saw the graph of a function, and I were to pass vertical lines over a function, any vertical line would intersect the graph at most one point. Numerically, this means if I was given a table, there'd be no repeated x values in the table. If we look at an example of something that's not a function, we have y squared equals x, and we ask, is this y a function of x? Clearly it's not, because if x equals 4, I have multiple values of y, 2 or negative 2. And we know we cannot have an input produce two distinct outputs. Remember, for one input there has to be a distinct single output. It also fails graphically with the vertical line test. Here's a graph of y squared equals x. Notice this vertical line hits the graph at more than one point. It also fails numerically because when we look at the table, I have multiple x values. In other words, they're the same x values listed twice, but they have different corresponding y values. This leads to the conversation of what a one-to-one function is. And this is important when we're talking about inverses. A one-to-one function basically means that given an output y, there's just one input x which produces that output. Numerically, that basically means there's no repeated y values in a table. Every x value will produce a different y value than what's already there. Graphically, it means that it passes what's known as the horizontal line test. So is y equals x squared one-to-one? Here's the graph of y equals x squared. Notice it does not pass the horizontal line test. It fails. Also, if x equals 2 and negative 2, y is 4. In other words, an item of the range is repeated. We look at the table and notice the y values are the same. Even though we have different x values, this still means it's a function because it passes the vertical line test. However, it's not a one-to-one function because it does not pass the horizontal line test. So let's introduce some notation. Given that a function is one-to-one, f is one-to-one, then f inverse, this is f raised to the negative 1 power, is the symbol for the inverse of the function f. Please don't confuse this with the reciprocal. F inverse of x does not mean 1 over f of x. These are not the same. So what exactly does the inverse function mean? Y equals f inverse of x basically means that x equals f of y. Let's look at examples. We know we can convert from Fahrenheit to Celsius and then again from Celsius to Fahrenheit. One of the functions would be f. Fahrenheit is a function of Celsius, which is 9/5 c plus 32. The question is, what's the inverse function? What is c equals f inverse of big F be? The original function multiplies c by 9/5 and then adds 32. To undo this, we need to reverse the operation and reverse the order. So we'd subtract 32 and then divide by 9/5. So f minus 32 divided by 9/5 is 5/9 times f minus 32. So here are our two functions. F of c is 9/5 c plus 32. F inverse of f is 5/9 f times f minus 32. Now notice for c equals 0, f of 0 is 32. And also notice for f equals 32, f inverse of 32 equals 0. So thus the point 0, 32 falls on the graph of f, and the point 32, 0 falls on the graph of f inverse. What's going to happen is that your domains and your ranges are going to be interchanged. Finding an inverse function. Let's first talk about how to do that. There's 4 steps you'll need to take to find any inverse functions. Typically when we're writing a function, we're writing with f of x. So to find the inverse function, we're first going to replace f of x with y. We do this because it's simply easier to write y than f of x. Next, we're going to swap x and y. In other words, replace every x with y and every y with x. We're then going to solve for y, and our last step is to replace y with f inverse. Let's look at an example. Find the inverse function of f of x equals 3x plus 9. First step, replace f of x with y. So I get y equals 3x plus 9. Then I'm going to swap the x and the y. So x equals 3y plus 9. Now I want to solve for y. I'm going to subtract 9 from both sides. We get x minus 9 is 3y. Then I'm going to divide everything by 3. X minus 9 divided by 3 is y. And so this now becomes my inverse function. F inverse of x equals x minus 9 over 3. This works for other functions that are not linear. Let's look at a cubic function. F of x equals x cubed minus 5. We get y equals x cubed minus 5 because we replace f of x with y. Swap the x's and y. We get x is y cubed minus 5. Solve for y. We get x plus 5 is y cubed. And suddenly the cube root of x plus 5 is y. So this is my inverse function. A formal definition of an inverse function is to prove something is an inverse. If let f be a one-to-one function, then f inverse is the inverse function of f if and only if f inverse composed with f of x equals x for every x in the domain of f, and f of f inverse of x equals x for every x in the domain of f inverse. This sounds like a lot, but it's fairly simple to do. Let's take two functions. I want to verify these two are inverses. I have f of x equals the cube root of x minus 6, and f inverse of x equals x plus 6 cubed. I have to show that f inverse of f of x equals x, and f of f inverse of x equals x. In other words, I want to compose both of these functions in opposite orders. So let's start with f inverse of f. This is f inverse. I'm going to put the f of x in the middle. I'm going to replace the f of x with the cube root of x minus 6. So f inverse of the cube root of x minus 6 simply becomes cube root of x minus 6 plus 6 cubed. The minus 6 plus 6 cancel. We get the cube root of x cubed, which is just x. I need to do the other way. F of f inverse, which is f of f inverse of x, which is f of x plus 6 cubed, which is the cube root of x plus 6 cubed, minus 6. Cube root of x plus 6 cubed is just x plus 6, minus 6, which is just x. So these two are definitely inverse functions. So why does f need to be one-to-one to have an inverse? Suppose f of x equals 2x squared. Then f of 2 is 8, and f of negative 2 is 8. If we calculate f inverse, then it would be possible to have two values, either 2 or negative 2, and thus f inverse would not be a function by definition. In other words, f inverse of 8 would either be 2 or negative 2, because remember the inverse function goes in the other direction. Let's look at numerically. Here we have a table of x values and f of x values. I want to find the inverse function. Remember the inverse function just swaps the domain and the range. So the point 1, negative 2, this was the domain of f, this was the range of f. So f inverse of negative 2 equals 1. It just goes in the opposite order. F inverse of negative 1 equals 2, again, the opposite order. F inverse of 0 equals 3. F inverse of 1 equals 4. F inverse of 2 equals 5. It maps back in the exact opposite order. It takes our ordered pairs and it reverses them. Let's look at evaluating an inverse function graphically. We know this function passes the horizontal line test. And we know the point 2, 8 is on the graph of f. And so if 2, 8 is on the graph of f, that means 8, 2 has to be on the graph of f inverse. So if I were to actually make this graph, here's my original graph. Here are points on the graph: 2, 8, 1, 2, 0, 0. So that means 0, 0 is also on the other graph. It means 2, 1 is also on the other graph, and 8, 2 is on the other graph. There's actually an imaginary line, this dashed line. This is y equals x. Okay? Y equals x actually creates a mirror image. If you tilt your head a little bit to the right at a 45-degree angle, this red line was our original graph. This blue line is our inverse function. Notice these are mirror images when compared and contrasted across this line here. And all we really did was swap the domains in the range. So the domain of f is the range of f inverse, and the domain of f inverse is the range of f.